Hello and welcome to our lessons on vectors and bearings. This is Malik. During our last lesson, we looked at bearing from one point to the other. This time we want to look at back bearing. What is back bearing? If the bearing of y from x is say theta, then the bearing of x from y is the back bearing, right? You realize that the first one says y from x is theta. Then the opposite, the reverse of it is just what we call back bearing. So for instance, if I have a point, this time I want to first of all look at the bearing of the bearing of y from x. So let's draw the bearing of y from x. Supposing I have, so this is my x. I have my x here. And we know our geographical north here. This is supposed to be at 90 degrees. And if I'm looking for the bearing of y from x, meaning I will have to assume that, for instance, this angle is our theta all the way to y. So this is my y, the point y. Right, and this is our theta. This angle is going to be our theta. So the angle theta here. This is our y and we have our north here. Therefore, if I want to look at the bearing of y, so the bearing of x from y, because the turning of this is y from x. So if we want to look at this angle all the way here, then that is what we call the back bearing. Right, so let's continue and look at how to solve for back bearing using, this is the diagram representation of the back bearing. So let's see, it says, this is a condition that has been given you. If the bearing of y from x is theta, as it was stated in the definition, then the back bearing, which is x from y, which is the back bearing, is given by, if the theta that was given in the question, you say theta plus 180 degrees, if and only if the theta that was given is greater than 0, but less than or equal to 180. So supposing the theta that was given was, say, 100 degrees. It's less than 180. So if you want to find the back bearing, you're just going to say 100 plus 180. And that's going to be the back bearing. For example, if the theta that was given in the question was, say, 70 degrees, then the back bearing will just be the 70 degrees plus 180 degrees, because the theta that's given is less than 180. Here is less than 180. But if the theta that was given, it says theta minus 180 degrees, if the theta that has been given is greater than 180, but less than or equal to 360. So for instance, if the theta that has been given in the question, let's go back to this particular definition. Supposing it says if the bearing of y from x is, say, 200, then the bearing of x from y is, which is the back bearing, will be what? Now, since the bearing that has been given here is 200, this 200, then you are going to use this particular idea. You are going to use this rule. So it's going to be 200 minus 180 degrees, since the bearing that has been given in the question is more than 180, right? So let's take examples and see how to do them. We're going to use this rule. And then after that, we'll draw it to see. So we're going to use both methods to see how we'll be able to arrive at the solutions. So let's look at the questions here. We have 4 questions, so I'm going to be doing 1 and 3 so that you do the rest. So let's look at the first question. It says if the bearing of A from B is 70 degrees, then find the bearing of B from A, which is the back bearing, right? So we have been given the bearing of A from B. So the one that always comes after the word from is your initial point. So A from B, meaning I'm at B, so I need to draw my Cartesian plane. Right, so this is my north. I got my 90 degrees here. And the angle that has been given, right? So even before going to draw this, let's use the first rule. Let's use the first rule here. We say if the bearing that has been given is less than 180. Now the question here is 70, right? So we're gonna say that the bearing of B from A is going to be equal to what? Since the bearing that has been given is less than 180, so we're just going to say 70 degrees plus 180 degrees. And that's going to give us what? 250 degrees. That's going to be the back bearing. So that is using the rule. But then I'm going back to drawing it to see if it's going to be the same. So the first one is we're starting from B. So our B, this is our position. We're starting from B, and it says it's 70 degrees. Therefore, I'm going to assume that we're going to take more than half. So B to A, right? And we know this is going to be 70 degrees. So we're now looking for the point A. This is our position A here. So we now have our north. We have our 90 degrees. This is going to be our 180 degrees, right? So now we are asking the question. We're going to use this diagram to see if it's going to be the same. Now the question is, find the bearing of B from A. It means if I'm now at A, this is our A, and I want to turn around. I want to turn all the way here to this point. How much turning am I going to do? That's just the question, right? How much turning am I going to do? Right, so we know from this point, I know from this point to this point is 90 degrees. From this point to this point is 180 degrees, right? How much more do I have to turn to get to this point, right? Now, let's go back to the idea, or let's go back to your geometry. You remember that if I have two parallel lines, so these lines are parallel, they're moving in, they are never going to tie. And there's a line that goes across it, like this. Then this line is called a transversal. The line, let me say AB. This line is, the line AB is a transversal. Now, immediately we have a transversal going across it. Then we are going to find an angle here. There's an angles are going to be formed all the way here. Angles are going to be formed. And immediately the angles are formed, we have co-interior angles, we have vertically opposite angles, and alternate angles, which we always call the Z angles. So automatically you realize that this angle here and this angle here, we always say they alternate. We always call them the Z angles. So let me use a different color to indicate those angles. You realize that this angle, right, the Z angle, this and that we always say is the same. Right, so when you bring that same idea here, if I want to continue to this point, let me continue up, we continue up, and then we look at the line that is in black, the black line, you realize that one is forming a transversal, and these are parallel lines. So automatically this point, this angle here, is going to be equal to this same angle here, right, because they alternate, right? So we're using the idea of alternate angle over there. It means this whole angle, let me use this color. It means this angle is also what? 70 degrees because they alternate. This is 70, this is going to be 70. And therefore, if I want to find the angle, the total angle from the whole of A, I'm turning, and we have to always start from the north. Therefore, if I'm turning from here all the way coming to this point, it's going to be 180 plus the 70. So we're going to have 70 degrees plus 180 degrees, which is going to give us what? 250 degrees, right? So you realize that this and that is basically the same, right? So someone will say, oh, that, but then we already had the answer from the simplest, using the simple idea, which is if it's less, we just add 180 and we got our answer. So why do we need to draw this? You need to draw this because when we go to do the main problem, which is the distance bearing problem, you will need to know how to do the back bearings and how to draw them. So that's why I took my time to draw this, for us to also see how it's also going to give us the same answers. Right. Thank you so much. So let's look at the example 3 and see what we're going to do. Example 3 says, if the bearing of y from x is 200. So bearing of y from x. So it means we're going to start from what? X. So I have my, let me draw my x here. This is my position x. Right? Always. You see, I was about to write the x here as my position, though I know here is always going to be my north. This is my 90 degrees. This is my 180 degrees. This is going to be my 270 degrees, right? So you see, I've written my x here. But I know from my question, I'm looking at 200. So within my mind, I have to think that, okay, 200 is not going to be in the first quadrant. It's not going to be here. Neither is it going to be here. It's going to be in the third quadrant. So therefore, I don't need to write the x here, right? So sometimes you have to just be smart and know that if I write the x here, the angle I'm going to be looking for is going to fall in the third quadrant here. Therefore, I don't need to write my x here, right? So I hope that makes sense, guys. So let me quickly clean this. So therefore, I'm not going to write this x here. I'm rather going to write it at a different spot, right? So therefore, I'm going to say my x. I know this is my position x, right? And we say that the bearing of y from x is 200, right? So it tells me that if I'm moving all the way here, I'm moving from n, I have to turn clockwise. So coming 1 is 90. If I come down again, it's 180. Now, how much more do I need to turn to be able to get 200? Right? I just need 20 out of the next, out of the third quadrant, 20, just 20 degrees of it to add to 180, and I'm going to get what? My 200 degrees, because I need 200 degrees. Therefore, 20 wouldn't be up to even half of it. Therefore, I'm going to, come all the way here. I'm going to say, let me use a different, I'm going to say, if I turn like this, it's going to be 20, so I'm going all the way to y, right? I'm going all the way to y. So I'm from x and I'm moving to y. So this is going to be my y. Let me draw the position of y. Right, so this is now my position, the position of y here. So, and we know that, let me go down, increase this. I know this particular spot I know this whole spot is just 20 degrees, right? So this is the position of y. This is y is here. This is my north and my 90 degrees. So the question now is, what is the bearing of x from y? It means if I'm at y2 and I want to turn to look at x from here, turn from the geographical north, if I turn all the way here, meaning how much do I have to turn to get to this particular line? You realize that this angle, so the idea of the alternate angles come in again. You realize that this angle and this alternate. So automatically, that is going to be 20. Right, so automatically this angle, I don't need to even work it. Automatically this angle is just 20 degrees because it alternates with this angle. So you're just going to say that, okay, I don't need to work it again because I already got automatic. So you're going to see the bearing of X from Y is 20 degrees. Right, so this is, 20 degrees. 20 degrees, right? So this is the drawing aspect of it, right? So let's look at using this idea, let's look at using this idea. I should have even done that one first. Let's look at using this rule. The rule says if it's more than 180. So when we go back to the question, it says the bearing of Y from X is 200. So the theta that is given in the question is greater than 180 degrees. Therefore, if you are finding the bearing of X from Y, it's just going to be the theta that has been given, which is 200, it's just going to be 200 minus 180 degrees. Because the formula says it's always supposed, since theta is greater than 180, it's going to be theta minus 180 degrees. And now our theta is this 200. So it's going to be 200 minus 180 degrees. And the answer is going to be 20 degrees, which is the same as when you drill it. When we drill it, we had the same answer. Right? Thank you so much for taking your time to listen to this. So you are going to do number 2 and 3 and send it to master. So in our next lesson, we are going to now be jumping into dealing with the distance bearing problem using all the lessons that